Good evening, students. Today's topic is uh, the class of P and NP, polynomial reduction, NP completeness problem, and NP hard problem. Then nowadays, the total research will be going on NP hard and NP complete problems. Then, before going to the NP complete and NP hard problems, then what is the P and what is an NP? We should know. Then coming to the our topic name is computational complexity. Then computational complexity amount of this will be the computational complexity will be run the P and NP problems. Then here you can see the computational complexity problem. The mainly we are focusing on two groups. One group is the P group and another group is NP group. P group and NP group. You can see here. Then P class and NP class. In that NP class, we have the NP complete and NP hard. Means we need to know the what is an P class, then what is an NP class, then what is an NP complete and NP hard. Then before moving to the NP complete and NP hard, then we need to know about the uh, what is an a polynomial time, what is an exponential time, then what is an a reduction, and what is an a deterministic things, and what is an a non-deterministic things. These are the very important things. Then you can see here, then P class versus NP class. Then P class versus NP class. Then what is an a P and NP? Then P is inside of NP. Then this is the important thing is P is inside of NP. Then P class is decision problems that can be solved in polynomial time. Then what is a polynomial time? Then the polynomial, this is the before exponential time. Then before exponential time means we can say order of 1 is a polynomial time, then order of log n is a polynomial time, then order of root n is a polynomial time, order of n square is a polynomial time, then n square, n cube, these all are polynomial time. Then what is an exponential time? The exponential time is the 2 to the power of n, 3 to the power of n, 4 to the power of n. Those are exponential time. Then P class means then the problem then we can solve and verify. Then whatever the problem you are taken, the problem verification and the problem solution we have got within the polynomial time. Then within the polynomial time means that is order of 1 or order of n, order of n square, order of n log n, order of log n. Means the within the polynomial time we get the verification and solution. Then we can say this is the P class, this is the belongs to P class. Then P class, what are the things are P class means insertion sort, bubble sort, binary search. These are the P class, merge sort. Okay, these are the P class. Then coming to the NP class. Then what is an NP class? The NP class is also decision problems that can be verified in polynomial time. Those are will be verified in polynomial time and using non-deterministic algorithms. Then now we need to know about the deterministic and non-deterministic algorithms. Then they can be verified within the polynomial time, but we cannot solve within the polynomial time. Means sometimes there may be we know some things, maybe you know robo. Then what are the robots? Standing robo, sitting robo, eating, dancing robo. These robots we know. Then robo have some feelings. Means angry robo, have you seen anywhere angry robo? No. If you have went to the hotel room, then if you are giving some order, then robo will go and bring the order, that's it. But Then if you are cancelled the order first time, second time, third time, fourth time, 10 times if you are cancelled the order, the robo never react, means there is no feelings to the your robo. Means these the research work is deterministic is today. Then what tomorrow? Then tomorrow maybe after 10 order cancel, then if you are writing the some programming, the robo have some feelings, means the robo can showing angriness. That type of programs we can we may be right, means uh, the feelings also coming to the robos. This is maybe possible tomorrow, but today there is no feelings to the robos. Okay, then I think you understand a little bit about the deterministic and non-deterministic means the verification and solution we got today, those are deterministic things. Then what is the non-deterministic things? The non-deterministic means today we know the problem, today we can verify the problem, means we can verify the problem, but today we cannot solve the problem, today we haven't the solution of the problem. And today is no solution, means what about the tomorrow? Tomorrow definitely we'll get the solution. Tomorrow definitely we can get the solution, maybe may not. Tomorrow maybe we'll get the solution, tomorrow may not we get the solution. Okay, those are non-deterministic things. Then you can see here, this is the polynomial time and this is the exponential time. Then what is the polynomial time? The linear search is order of n, linear search, sequential search, order of n. Then binary search, every time we need to divide half of the part, means log n. Then insertion sort means the n square. Then merge sort, n log n. Matrix multiplication, we have the for loop within another for loop within the another for loop, then n cube. Then these all are within the polynomial time. Then what is the exponential time? Exponential time means 2 to the power of n, 3 to the power of n, like that. 0 by 1 knapsack problem. What is a 0 by 1 knapsack problem? We have one bag. In that bag, we need to fill the weights. How many weights we are filling? Until the bag capacity should be reached, then we can fill the weights, yes or no? Then uh, how much capacity of the bag, we don't know. Then how much capacity, you know, then you can take the capacity. That's why then we can say the 0 by 1 knapsack problem have the time complexity, we cannot finish within the polynomial time, then this will be exponential time. Then traveling salesman problem. Then traveling salesman problem, he can travel within the location, then within the city, within the country, within the world also possible. Means we need to find the source to destination. We need to find the source to destination. Then he can travel entire world. Means this is traveling salesman problem. Also, the time complexity is what, exponential 2 to the power of n. Then next one is graph coloring. The graph coloring means we need to give the coloring to the nodes. Then how to give the coloring to the nodes? No two neighbors have the same color. Means a good example is the map coloring. Then map coloring means what is the meaning of map coloring? The map coloring means we have the countries have some states, in that states have some cities, then two neighbor cities have the not same color. We can take the three different colors, RGB color. Those RGBs we need to fill the with the cities. Then R and G, those are should not be R and R, the same color should not be in the neighbor nodes. Okay, that problem is graph coloring problem, map coloring. Then map coloring also is, we can coloring normal state, maybe the city, maybe the country, maybe the world. It's not simple problem. That's why the time complexity is what, 2 to the power of n. Then next one is Hamiltonian cycle. Then what is an Hamiltonian cycle? The graph in that graph, it should be the in that graph it should be fill the total nodes. Visit the total nodes. Then in your graph we have the many nodes. Then we need to fill the total nodes. Total nodes. Yes or no? Means uh, the the Hamiltonian cycle visit the all nodes, whatever the nodes there in your graph, we should visit the all nodes. Then finally sum of subsets. The sum of subsets means we have some we have the big set. In that we can take some set, one or two sets or three sets. Those sets should be equal to the sum. Then you have some idea about the polynomial time and exponential time. The polynomial time is order of 1, order of n, log n, root n log n square, n cube. These are the polynomial time. Then exponential time is 2 to the power of n. Then whatever the exponential time is there, those exponential time things are non-deterministic. Example, then I am in Kakati University. I want to move Kazipet. Then what is the route from Kakati University to Kazipet? We need to source is the Kakati University. The next point is what is the next point? Petrol pump. Petrol pump to Kazipet. What is the one route? Another route is what? Kakati University and Fatima Nagar and Kazipet. Then from these two are the results. From these two are the results. Then what is the first result? The first result may be 20 kilometers. Then second result may be 15 kilometers. Yes or no? Then example first one is 17 kilometers, second one is 15 kilometers. But both are the solution. But not same. Not same. It is non-deterministic. Now, then which one is optimal? Definitely which one is the least value, that is an optimal. Then and one more thing is, every problem we can solve with five methods. What are the five methods? One is divide and conquer, second one is greedy method, third one is the dynamic programming, fourth one is backtracking, fifth one is approximation algorithm. Using these five algorithms, five approaches, five methods, we can solve the problem, but results are not same. The results are not same, and we maybe get the optimal solution, we may not get the optimal solution. Then what is an optimal solution? Optimal solution means what? The best solution. The best solution will get from within five methods: dynamic programming, greedy approach. Okay, then dynamic programming, greedy approach, divide and conquer, and backtracking and approximation problem. Then using these methods, we'll get the so many results. So many results. I'm saying you know 2 plus 3. What is the value? 5. That is deterministic. Today is 5. Tomorrow is what? 5. Day after tomorrow is 5. But sometimes results are not same. Example, traveling salesman problem. One results. KU to petrol pump to Kazipet 17 kilometers. KU to Fatima, Fatima to Kazipet 15 kilometers. Which one is optimal? 15 is optimal. But some methods will give 17, some methods will give 15. It's possible. The results are not same, means non-deterministic. Then you can see what is an a deterministic, what is an a non-deterministic. A deterministic algorithm produces only single output. Deterministic means it produces only single output, one output. A non-deterministic algorithm can provide different outputs, different outputs. Example, for the same input, even or different runs. Same input, even or different runs. Then the same input on different runs means we have the different outputs with same inputs. It is non-deterministic. We have same inputs, same outputs is deterministic. Example, this is a q. We have the different inputs, 1 and 0, 1 and 0, different inputs. That's we have different inputs means different outputs. Different inputs means we will get the different outputs. You can see here, we have the q, one input, we get the q1 different output, q1 is different output. Then q0 input, we got the q2 is different output. Means this is what deterministic. Then q, same input means 0 0, same input, q naught, q naught, q naught, there is no change. But you can see in the non-deterministic, the input is what, 0 0, but output is what, q1 q2, means different. The non-deterministic means the non-deterministic algorithm can provide different outputs for the same input. Then what is an deterministic? Will get the single output from same inputs. Okay, I hope you'll understand deterministic and non-deterministic, three things. Then what is the first one is, we are in p and np, p class and np class. In that p, we have the uh, finish the problem within the polynomial time. Means we'll get the verification and we got the answer within the polynomial time is p. Then np is, we can verify it within the polynomial time, but we cannot get the solution is non-deterministic and np. Then deterministic means what? Same inputs, same outputs. Non-deterministic means same inputs, different outputs. Example, today 2 plus 3 is 5. Tomorrow 5. Day after tomorrow 5. If you are getting 2 plus 3 tomorrow 6, that is non-deterministic. Is it possible? Yeah, some problems may become possible. I already told na. Here to Kazibet, one route is 15 kilometers, another route is 17 kilometers. Those are non-deterministic. Okay, then you can see a non-deterministic searching algorithm. How many searching algorithms you know? Maximum we know the two searching algorithms. One is linear search, second one is binary search. Then what is the time complexity of linear search? Order of n, means we need to search 1 2 3 4 5 sequential way. Then binary search means what? Every time it will be divided into off 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 off. We need to find the element, yes or no? Then that is a binary search. Then what is an time complexity? N by 2 means order of n, order of n, half n by 2 means log n. Then what is an a linear search? N. This is the non-deterministic algorithm. We have the choice, success, failure. Take the choice, search the element, either success or failure. That is the n search algorithm. Is it non-deterministic? అలాంటి అల్గారిథం ఉందా ఇప్పటివరకు? ఎక్కడైనా చూస్తున్నారా? అంటే ఇప్పుడు లీనియర్ సెర్చ్‌లో ఒక 1000 ఎలిమెంట్స్ ఉంటే 1-1000 వరకు సెర్చ్ చేసుకొని పోతాం. అది లీనియర్. బైనరీ సెర్చ్ అంటే ఏంటిది? సగం సగం డివైడ్ చేసుకుంటూ సెర్చ్ చేసుకుంటూ వెళ్తాం. ఇప్పుడు ఏమంటుందంటే నాన్ డిటర్మినిస్టిక్ ఏమంటున్నదంటే సింగిల్ చాయిస్‌లో మనకి అవుట్‌పుట్ రావాలా. అంటే ఇప్పుడు డైరెక్ట్‌గా 500 ఎలిమెంట్ అంటే ఆ 500 ఎలిమెంట్ పొజిషన్ దగ్గర సక్సెస్ రావాలంతే. సింగిల్ సెర్చ్ చాయిస్ 1, n, then I want to get the element success, I'm not get the element failure. So highly impossible. This type of algorithm still nobody not written. ఇప్పటి వరకు సింగిల్ సెర్చ్లో ఎలిమెంట్ ఫౌండ్ చేసే అల్గారిథం మనకు రాలేదు. దట్స్ వై దట్ ఈస్ వాట్ నాన్ డిటర్మినిస్టిక్. Today is non-deterministic, maybe tomorrow deterministic, but that much knowledge, that much of knowledgeable person we cannot seen in the country. Okay, still in the world, this type of algorithm, single search algorithm, single attempt, we need to find the element. That type of algorithm is not there in the research. We haven't we haven't that type of algorithm. That's why it is non-deterministic today, then maybe tomorrow maybe deterministic. Is it clear, student? My voice, is it clear? Any network issue? Is it clear? Then next one is, we'll move to the NP hard and NP complete. Then NP hard and NP complete. Then what we are covered the topics. One is the P is a polynomial time, NP non polynomial, and non deterministic, and deterministic and non deterministic, and polynomial time and exponential time. Now we'll see what is an NP hard and NP complete problems. Then we know the NP hard and NP complete. For understanding the NP hard and NP complete, first you should understand the reducibility. Then if you are understanding the reducibility, then you will understand the NP hard. Then after you will understand the NP complete. Then you can see the NP class problem can be further categorized into NP hard and NP complete problems. Then what is an NP hard problem? A problem is NP hard if all other problems in NP can be polynomially reduced it. Then what we need to do the NP hard? We need to do the polynomially reduced it. Means it is the non-deterministic things. The non-deterministic things we need to do the polynomial reducible. Then polynomial reducible means, uh, the heuristic algorithms. Heuristic algorithm, example I'm saying traveling salesman problem. I'll show the traveling salesman problem, then you will understand the concept. Dear students, have you seen the my laptop? Please, please, please speak. Please, anyone on your mic and speak, because then I will show the what is an approximation things. Then how it will be worked. Then you can see. Students, have you seen this PPT? Please. Hello. Please speak. Yeah. Yes. Okay. Thank you. Then you can see the PPT. This is the problem. This is what traveling salesman problem. The traveling salesman problem we need to solve with approximation algorithm. Then how to solve this one? The traveling salesman problem have direct solution with greedy methods and backtracking and dynamic programming. We have direct solutions, but we need to depending on some heuristic algorithms. Example, if you want to solve this traveling salesman problem, you should know the first you can find the minimum spanning tree. Then after you can traveling the pre-order traverser. Then you will get the then next one is you can find the Hamiltonian cycle. Then you can see the step one is choose any vertex of given graph, then starting point and ending point, and construct the minimum spanning tree. Then next one is after construction of minimum spanning tree, then we can traveling the pre-order traverser. Then next one is find the Hamiltonian path. Hamiltonian path means visit the all solution, then we'll get the answer. You can see here, this is the graph. We have one connected to 210, two connected to 312, two connected to 510, five connected to 6 8, and three connected to 4. This is normal graph. This normal graph, first step, we need to MST. Then we need to construct MST. MST means minimum spanning tree. Then if you are construct the minimum spanning tree, you need to use the Prim's algorithm. I'm using the Prim's algorithm. I construct the minimum spanning tree. The starting point is 1, then 1 is connected to 2, then 2 is connected to 5, then 5 is connected to 6, then again right side 2 is connected to 3, 3 is connected to 4. Then this is the what spanning tree. Then next one, after construction of spanning tree, then here I perform the pre-order traverser. Then what is an pre-order traverser? Root left to right. Then using that algorithm, root left to right, then we are traveling the elements 1 2 5 6 3 4. Means we need to visit the all nodes. If it is if visit the all nodes means Hamiltonian cycle, then visit the all nodes, then this is the Hamiltonian cycle. The finally we can calculate the cost. Then what is then cost? 55. Okay, this is the traveling salesman problem using approximation algorithm. Here we are using heuristic algorithms. Well, what is an heuristic algorithm? Means we are joining more than one algorithms. Okay, then means for solving the traveling salesman problem, we are using MST, using Prim's algorithm. And second one is what? Pre-order traverser. And third one is what? Hamiltonian path or not, we are verified. Means when we are using these three techniques, means minimum spanning tree, Prim's algorithm, traveling salesman problem, then next one is pre-order traverser, then Hamiltonian path. Using these three uh, steps or three techniques, we are solving the traveling salesman problem. Means one complex problem, we need to solve it some other techniques, similar techniques, known techniques, is called reducibility. Then what is an reducibility, that we will see now. Then then reduction. Then reduction means capital A. Then let A and B are two problems. Let A and B are two problems. Then problem A reduced to problem B if there is way to solve the problem A by deterministic algorithm that solve problem B in polynomial time. Example, then B is a polynomial time. Then what is an B? B is a polynomial time. That means B problem we can solve within the polynomial time. Then A we cannot solve in polynomial time. But we know the B, we have the B algorithm. We haven't A algorithm. We haven't A algorithm. But using B algorithm, we can solve A. This concept we are calling reduction. Means A proportional to B. Then how it will be work, we'll see. You can see here. Then reduction, consider we have two decision problems P1 and P2. Then what is the two decision problems P1 and P2? Means the decision problem means what? Yes or no. Then P1. Then what is an P1 input? I1. Then what is an algorithm? A1. Then what is an A1? Unknown. I don't know. But Example, I don't know the I haven't algorithm, but I need to solve. Then how it is possible? Example, I don't know the concept of NP hard, but my friend know the concept of NP hard. Then if he explained to me NP hard, then I am also know the concept. Means is the polynomial time, I'm the non-deterministic thing. When he's explained the things, I am also known. Yes or no? Means this is the concept of reduction. Then P1 is input I1, then algorithm A1 unknown, we don't know the algorithm. P2 is the input of I2, algorithm what? A2 known, A2 we know. Example, traveling salesman problem is P1, we don't know, but we know minimum spanning tree Prim's algorithm, we know pre-order traverser, we know another thing. What is another thing? uh, Hamiltonian cycle. If we know these three things, we can solve the traveling salesman problem. Means MST and pre-order traverser, and last one is Hamiltonian cycle. Using these three, we are solving traveling salesman problem. Then P1 is unknown, then P2 is known. P1 input is I1, P2 input is I2. If P1 can be solved with the help of A2, P1 with the help of A2 means P2 algorithm. A2 is what? P2 algorithm. P1 solve with A2. Then we convert input I1 to I2, then find the solution of P2. And indirectly P1 is reducible to P2. Then using the A2 algorithm, we are solving the P1. Then you can see this architecture. I1 is input of P1 using some function. F of I means using some function. Then we are converted to I2 using some function. I1 converted to I2. Then I2 means it will be working algorithm A2. Then we will get the output, the solution. Example, nowadays we are using convolution neural networks, then recurrent neural networks. All artificial intelligence concepts are present non-deterministic things to deterministic. We don't know the answers, but whatever the known things are there, using the known things, we need to solve the unknown things. Is it clear? Then this concept is what? Reducible concept. Okay. Then I1 function f of I, then sending the I2 the algorithm, then produce the solution. Then if you know the reduction, if you know the reduction, then you will understand the NP hard. A problem NP hard if all other problems NP can be polynomially reduced it. Then example, one non-deterministic converted to deterministic, that is reducible. Then two second one also non-deterministic converted to deterministic. Then third one is also non-deterministic converted to deterministic. Means if you are solving non-deterministic to deterministic, then this type of things we are calling NP hard. Then what is an NP complete? NP complete is union of NP and NP hard. Then you can see here this one. Then this is the NP. The small thing is the P. The small thing is a P. Then this total one is NP. Then this is NP hard. NP hard. Then what is the part? This part is NP complete. This part is what? NP complete means. This is the union of NP and NP hard. Then what is an NP complete? The NP complete, we can say the union of NP and NP hard. Then we'll see the table. What is an P? What is an NP? What is an NP complete? What is an NP hard? Then first one is P. The P is a tractable. We can verification and solve uh, within the polynomial time. Then you can see solvable within the polynomial time. S. Then verifiable within the polynomial time. S. Complexity is what? Easy. It's not exponential. It is in a polynomial time. That's why it is solvable and it is verifiable and the complexity is easy. Then NP is intractable. Intractable means it not be deterministic. Then we can verify but we cannot solve within the polynomial time. Then what is the complexity? The complexity is the medium. The complexity is what? Medium. Then third one is NP complete. Then NP complete means the decision oriented things. Then S or no, like the decision oriented things. We can verify it, but hard means we need to apply the reduction algorithms. It is verifiable in polynomial time, but complexity is what? Hard, because we have the many NP problems. Always we need to reducible and solve the problems. Example, nowadays research is what? Multimodal things. The previously we are solving with the image, or we are solving with the text, we are solving with voice, we are solving with video. Different modules. uh, what is text, audio, video, and images, different modules. Nowadays we need to combine the two things, fusion the things: text and image, voice and text, voice and image. These the combinational things and the hard. Then decisions, which one we need to take: image and text, yes; video and voice, no; voice and text, yes. Like the decision things are what? NP complete. This the decision things are the combination of NP and NP hard. Then last, the next one is NP hard. Then what is an NP hard? Optimal solution, optimization. Very hard. We need to apply the reducibility. We need to apply the reducibility. The optimization techniques we need to use. Then we need to find the optimal solution. Actually, approximation algorithms always give the nearby solution but not total. Then you can see here this one. uh, you can see this one, approximation algorithms. You can see here. Then these are the approximation algorithm. Then approximation algorithm is always dealing with the NP completeness for an optimization problem. This technique does not guarantee the best solution. This one is does not guarantee the best solution. The goal of the optimization algorithm is to come as close as possible to the optimal solution, means nearby the optimal solution. Example, here to Ku to Kazipet. Then what is the distance? K to Kazipet, the optimal solution is what? 15 kilometers. Optimal solution is what? 15 kilometers. Then you are getting 16 kilometers. Answer is 16 kilometers. Actual optimal solution is 15, but you are getting 16. Example, another example. Actually you want to get the 15 is answer, but we are getting the 15.1. 15.1 is nearer by to 15, closer to the optimal solution. Then heuristic things, approximation things, those will be provide the optimal solution. Example, then you know the COVID situation, that those are set cover things. You can see here, the COVID. uh, how to recognize the COVID. Then there is some sets. Example, there is some set, I have dry cough and headache, I have some cold and cough, I have body pains. Yes or no? This type of sets, then you can combine those sets. You can combine those sets. You will get the answer. You will get the answer. Then you can see this set cover problem. In that set cover problem, some things. What you know some sets. Then there is a combinational of sets. The combinational of sets, then if you are combining the sets, then you will get the answer. Example, the universal set is 1 2 3 4 5. Universal set is what? 1 2 3 4 5. Means I need to cover all these things only, then I can tell the you have the disease or not. Example, if you know the fever, I can tell, if you know the fever, cold, cough, dry cough, body pains and headache, and vomitings, okay, fever, these things all are, if you have, then I can tell you. And then what is the nose problem and oxygen problems, these type of things, if you know breathing problems, if you know these all symptoms, then we can say you have the covid positive. Then there is some subsets, S1 1 2, S2 2 3 4, S3 4 5. Means these some subsets will be covered. One subset cold and cough, another subset fever, body pains and headache, another subset is what? Breathing problem and fever. When we are combine these three things, it will be cover the universal thing. Then under universal thing అంటే కోవిడ్ కున్న లక్షణాలన్నీ కూడా ఒక్కొక్క సెట్ నుంచి చెప్తున్నా. కొంచెం కొద్దిసేపటికి పేషెంట్ పోయి డాక్టర్ దగ్గర పోయి, డాక్టర్ నాకు హెడేక్ ఉంది, ఫీవర్ ఉంది, నాకు కొద్దిసేపు అయిన తర్వాత కోల్డ్ ఉంది, తర్వాత థ్రోట్ పెయిన్ ఉంది, ఇవన్నీ ప్రాబ్లం ఒక్కొక్క సెట్లో చెప్తున్నాడు. ఈ సెట్స్ అన్నీ మనం కంబైన్ చేస్తే యూనివర్స్ సెట్కి ఒకవేళ ఈక్వల్ అయితే అప్పుడు మనం ఏం చెప్తాం? ఈజ్ ద పాజిటివ్ పేషెంట్. దీస్ టైప్ ఆఫ్ థింగ్స్ ఆర్ ఎన్పి కంప్లీట్ ప్రాబ్లమ్స్. ఓకే, దీస్ ఆర్ ద డెసిషన్ ప్రాబ్లమ్స్, approximation problem. Then NP hard is the optimization, means we'll get the optimal uh, solution. Okay, then this is the reduction. Okay, then you can see the properties of reduction. Then coming to the properties of reduction, a is proportional to b. A is proportional to b. Then what is the meaning of a is proportional to b? Then a is solved with b help, means b have the known solution. If you b have the known solution, then we can solve the a. Then if the b is also unknown solution, is difficult to solve the problem. Then a proportional to b in means b in polynomial time. A is a non-deterministic, b is a deterministic. If the b is deterministic and that solution is useful, then a also solved. That's why a proportional to b, a in p. Then second one is a proportional to b and a is not in p. A proportional to b and a is not in p means a is not in p means a is not polynomial time. A is not in deterministic. Then a is not deterministic. A we cannot solve within the polynomial time. Then how we are saying uh, a proportional to b? Because b is not in p. If a proportional to b, a is not in polynomial time, then b is not in p. Then b is also not in p. Means b also we cannot solve within the polynomial time. Sometime the research today may be deterministic, tomorrow may be non-deterministic. Sorry, today may be deterministic, tomorrow may be non-deterministic. Some things today may be non-deterministic, tomorrow may be deterministic. Today we haven't solution, but tomorrow maybe we'll get the solution. Today we have the solution, but tomorrow we need to improve the solution. Okay, these all are happening in the research. That's why the NP problems are at last unit. Then this one will be help to your artificial intelligence, deep learning techniques, computer vision things, then all the new things, whatever the, if you are entering the in industry, you need to do the so many prediction problems, so many detection problems. You need to work on Amazon, means you need to Azure technologies. Okay, these all are user interface problems. These are things you should solve with the uh, polynomial reductions and approximation problems. A is in decision problem and B is optimization problem. Then what is a decision problem? A is in NP complete and B is NP hard. Then we can say A proportional to B, because the NP complete problem and B is an optimization problem. Optimization, definitely we can reduce the problem using the reducibility. That's why A proportional to B. Another one is, with the help of A we can solve B. With the help of B we can solve C. That is possible. A2 we find the, with the help of B we can solve A. With the help of C we can solve the B. Means the transitive relationship A to B and B to C, then indirectly A to C, means A proposed to C. This is the transitive relationship also possible. Then second one is, sometimes A proportional to B is possible and B proportional to A is possible. Then both are A and B polynomial equivalent, means both have the strongest algorithms, both have the well known algorithm, its own solutions. Then also we can solve the problems. Then finally satisfiability also. Okay, then dear students, hope you all understand the NP hard and NP complete. And four things. What is the first thing is, P is a polynomial time, and second one is NP is what, non-polynomial, non-deterministic things. Then just we can recall the things. Then P is what, P class and NP class. Then P is a deterministic time, and we can verify and solve within the polynomial time. NP is have NP complete and NP hard. Then P is verified and solved within the polynomial time. Then next one is what, NP class. NP class means what, it is verified within the polynomial time, but we cannot get the solution within the polynomial time. Then what is a polynomial time? The polynomial time is n log n square, n log n cube. Then exponential time example is what? 2 to the power of n time. 0 by 1 knapsack problem, traveling salesman problem, graph coloring problem, Hamiltonian cycle, and sum of subsets. Then what is deterministic and non-deterministic? Then deterministic means we have the different inputs, different outputs, and same inputs, same outputs. Input never change today and tomorrow forever. Those are deterministic. The non-deterministic means what? Then the Q is what, zero. I means the same inputs but different outputs. Those are non-deterministic. Then today non-deterministic, tomorrow may be deterministic. Today non-deterministic, tomorrow also non-deterministic, because we cannot say. Example, the robo have the feelings, angriness, sadness, crying. That is what today non-deterministic. What about tomorrow? We don't know. Maybe robo will get the angriness tomorrow, that type of programming if you are writing. then that is deterministic. If you won't write that type of programming, that is non-deterministic only. Example, single way of search algorithm. Then single way of search algorithm means one way of search algorithm. Single attempt we need to get the solution. That type of algorithm today not there. Then tomorrow maybe get the solution. Then tomorrow it will be deterministic. But today is non-deterministic. Tomorrow also not getting the solution means tomorrow also non-deterministic. Then next one is the this is n search algorithm, non-deterministic searching algorithm. Then coming to the NP hard and NP complete, then NP class problem can be further categorized into NP hard and NP complete. Then NP hard, if all other problems in NP can polynomially reducible, you should reducible the things. Example, traveling salesman problem. Then how to polynomial reducible? Using heuristic algorithms. One is MST, minimum spanning tree, using Prim's algorithm. Second one is uh, pre-order traverser, route left right. Then third one is Hamiltonian path or not. These three techniques we can use you and we can solve the traveling salesman problem. Then NP complete is the combined of NP and NP hard. Then you can see this is the diagram. This is diagram will be explained what is an P, what is an NP, what is an NP hard, and what is an NP complete. P is under NP, NP hard is separation, and we are applying the reduction. Then NP complete is the union of NP and NP hard. Then these are the table explaining about the P and NP, NP complete and NP hard. P is always tractable and easy solution and verification possible within the polynomial time, and NP is intractable, then we can verify but we cannot solve within the polynomial time. We cannot give the assurance to solve the solution within the polynomial time, but using the reduction techniques and satisfiability methods we can solve the problem. That's why the complexity is medium. Then coming to NP complete problems, those are decision making problems, yes or no like that. Then those are hard. Then NP hard is optimization problems, the hardest one. Then coming to the reduction, then you know A problem and B problem. Then A is unknown algorithm, then B is a known algorithm. Using this known algorithm, we can convert A to B. We can transform from A to B, then we'll get the solution. Example, this is the P1, then input I1, algorithm A1 unknown, then P2 input I2, algorithm A2 known. Then P2 is a known algorithm, then P1 is unknown algorithm. Then using some functions, then I1 input transform to I2. Then if your I1 input transform to I2, then I2 will be entered in A2, then we can get the solution. Just you can change the input. Then how to change the input? There is some functionalities. Whatever the functionalities you want to use, you can use those functionalities and change the input I1 to I2. If you see this example, the input for problem P1, function f of I, using this function transform to I1 to I2, then I2 entered into the algorithm A2, then get the solution of P1. Okay, then we are using A2 algorithm, we get the solution of P1. How we are get the solution of P1? Using A2 algorithm. Then A2 algorithm, which input it will be take? I2 input, but we have I1 input, means we need to convert I1 input to I2 input using some function f of I, some functions. Then only that will be entered in algorithm, will get the solution. Then conversion of I1 to I2 using some functional functions. Then whatever the techniques, whatever the how to work the algorithm, if you know how to work the algorithm, you should change the inputs using some function f of I. Then we can use those the known algorithms, whatever the known algorithms is there, we can use and we can solve the problems. Then next one is, this is the properties of reduction. If a proportional to b means b is known, a is unknown, using b we can solve a. Then a proportional to b, a is not in polynomial, then b is also not in polynomial. Then next one is, a is decision problem means np complete, b is an optimization problem np hard, then we can say a proportional to b. Then third one is, a proportional to b and b proportional to c means, then a solved by b using reduction, b solved by c using reduction. Indirectly a also we get the solution a proportional to c, that is a transitive property. Then sometimes a proportional to b and b proportional to a, both are polynomially equivalent, both have the strongest algorithms, strongest solutions, and strongest things, then we can say a and b are polynomially equivalent. Then last one is satisfiability of a. Then when the satisfiability of a, then a is np hard, the np hard. Okay, this is about the p class. This is about the p class, np class, polynomial reduction, np completeness problem, np hard problem. Okay, my name is Johnson Colluri. I am working as an assistant professor, School of Computer Science and Artificial Intelligence, SR University. Then if you have any doubts, you can communicate with me. My email id is johnson.colluri@gmail.com. Then another, you can see here, this is my email id. Then if you want to, you can communicate with my email id, johnson.colluri@gmail.com. This is my personal email id. Another one is johnson.colluri@sru.edu.in. Then if you have any doubts regarding any topic, you can just mail me. Then definitely I will clear your doubts. Hope you are understanding. Then hope you have some uh, clarification of p, np, and np hard, np complete, reduction, satisfiability. Thank you. If you have any queries, just you can ask me, then I will clear your doubts.